This is lesson 7.1, sequences and series in college algebra. We're just getting ready to start a new chapter. So we're starting on page 576, and we're going to start out with sequences. Middle of the page there, it says a sequence is a function where the domain, the input, or the x value, is a set of consecutive positive integers beginning with 1. Okay, so a sequence is therefore a function whose first term is going to be consecutive positive integers. And then when we put it in the function machine, we put it as an input. What it kicks out is what's going to go right here. And in the example they gave us, they said that if we put $1,000 invested at 6%, compounded annually, after 1 year we would have 1,060. So with our 1 is our domain that we put in there. After 2 years, there would be $1,123.60. Okay, and then for year 3 there'd be an amount, year 4 there'd be an amount, etc. And that would give us a sequence. Now if this domain 1, 2, 3, 4, 5, 6, 7 went into infinity, it never stopped, we just kept adding another year or another, a number, a positive integer, that would be called an infinite series because it goes on forever. Our x value goes on forever. If it stops somewhere, maybe we just want to know the first 10 years, so it would stop at 10, that's called a finite sequence. So obviously it stops. So bottom of page 576, sequence is an infinite sequence, has as its domain the set of positive integers, 1, 2, 3, 4, 5, dot, 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 meaning it goes into infinity. And a finite sequence is a function having for its domain a set of positive integers, 1, 2, 3, 4, 5, dot, 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 and then notice it has the n afterwards, means it will stop at some number. We don't know what it is. It could be 10, it could be 20, it's whatever we decide that we're going to stop. Then it becomes a finite sequence. Okay, so there are values to a sequence, and they're called terms. So, this right here is a term, and this right here is a term. They both have values. And the first term of a sequence is denoted by A1. Okay, so that means that's the first number. It could be the number 1, it could be the number 6. Wherever we're starting, that is the first term of our sequence. The fifth term of our sequence we would denote with A with a subscript of 5, etc. The general term, which means we don't know what term we're looking at, we're just going to call it n, and that just means it's the unknown term. There is a number there, but we don't know what it is. So example 1 says, let's get rid of all this. It says find the first 4 terms and the 23rd term of the sequence whose general term is given by a to the n. So this is the general term. This is the equation we're going to look at in order to find our answer. Negative 1n to the n squared. Okay, so it's asking for the first 4 terms. Well, if we want to find, let's say we're going to find the second one. Now wherever we see an n, we're going to put a 2. So then we've got 1 times 4, which is going to be 4. And it wanted the first 4. So it wanted when n is 1, when n is 2, which we just found, when n is 3, when n is 4, and when n is 23. So then we'd put a 23 in for here and for here. So note that in example 1 that the power negative 1 to the n right here, all that does is causes the sign of this to alternate. Okay, we had studied this back when we were doing matrices. If we have a negative 1, if this is a 2, then our answer is going to be positive. If this were a 3, our answer is going to be negative. So whenever n is an even number, our answer will be positive. Whenever our n is an odd number, our answer is going to be negative. And when you have something like this, a negative 1 to the n power with other stuff, what this is doing is determining what sign we're going to put on our answer. And this kind of a sequence that's written like this with this negative 1 to the n power is called an alternating sequence, because our answers as we go up are going to change from positives to negatives. All right, so we can graph a sequence, top of page 578, just as we graph other functions. So consider the function given by f of x equals x plus 1, which draws that straight line on the left-hand side of the page. The graph of f of x equals x plus 1 is shown on the left. If we remove all the points from this graph except those whose first coordinates are positive integers, we have the graph of the sequence, a to the n of n plus 1. So what they're saying there is, remember when we were talking about what a sequence is, the domain, the first value, has to be a positive number, and it has to be one of the counting numbers. It can't be a fraction. So therefore, it's not going to draw a straight line. If your x values are only positive integers, it's only going to be dots that are in the form of a straight line, like the graph on page 578, right-hand side. All right, next part is finding the general term. All right, finding the general term means we're trying to figure out what kind of formula we're using in order to get the answer. So, for example, example 2a, they give us 1 square root of 2, square root of 3, 2, dot, dot, dot. So they gave us the first four elements of the sequence, and they're asking us to find the general form. So how do we get those answers? What do we have to do to a number to get those answers? Well, what we're going to end up doing is we are going to do 1, and what we're looking for is the range, or the output here. So if we put 1 in, how do we get 1 for an answer? Well, if we take the square root of 1, we would get that. What if we put in 2? Well, then it would kick out the square root of 2. So if we use the square root of n, where we put in the numbers 1, 2, 3, 4, we're going to get as our y values these answers right here. So what we're trying to do when it says finding the general term, we're trying to find out our function machine here. Remember from a long time ago? You'd put in a number here. What's it going to do when it's in here in order to spit out our answer? So if we put in a 1, what's it going to do inside of here to spit out a 1? Well, it's going to take the square root of 1. If we were to put in let's say we put in a 3, it's going to spit out a square root of 3. If we put in a 4, it's going to spit out a 2. And see how that follows in line here with this? We put in a 1, it spits out a 1. We put in a 2, it spits out a square root of 2. Put in a 3, a square root of 3. Put in a 4, it spits out a 2. So our general term is the square root of n right there. So some of these are pretty easy. Some of them are a little bit trickier. So for example, negative 1, 3, negative 9, 27, negative 81. Okay, so what I'm noticing there is there's some kind of root there, because I'm going from 3 to 9, so I square 3 and I get 9. I take 3 to the third and I get 27. I take 3 to the fourth and I get 81. But what happens is they're alternating. So that means I have to use the negative 1 to the n power there in order to get them to alternate. And I also have to take a 3 and figure out a way to get from 1 to 3 to 9 to 27. Well, how do I get from a 3? I mean, I can get from 3 to 3. I mean, that would be 1, and this would be 2, 3, 4. But how do I get a negative 1? 3 to what power is negative 1? Okay? So if again, we start with positive integers. So I'm going to have to start with 1. N is always going to be starting with 1. So what I'm going to do here is I'm going to put up here an n minus 1. And what happens is when I put in an n minus 1 and I start at 1, 1 minus 1 is 0. 3 to the 0 power is 1. And if I put a 1 here, that's an odd number as an exponent, meaning my answer is going to be negative. So see how tricky it can be? Your first n is always going to be 1. And then it's going to go 2, 3, 4, 5. No fractions, no decimals, no negatives. It will start with 1. So when I put in n is 1, I'm going to get a negative 1. When I put in a 2, what's going to happen? I have 3 to the 2 minus 1, or 3 to the first power. So I'm going to have 3 here, and I'm going to put a 2 here. Negative times a negative is a positive, so therefore I get a positive 3. I put in a 3. 3 to the second power is 9, and I put in a 3 here. It's odd, so it's going to keep that negative, so it gives me a negative 9. So see how it works? My domain is always going to be 1, 2, 3, 4, 5, etc. I just have to figure out what I'm going to do to the 1, 2, 3, 4, 5 to get these answers. And that is called your general term. And that's what this is right here. What formula do I have to come into so that when I put my x into the function machine, it's going to kick out a 27. So what happens in here? Well, this is what happens in my function machine. So that's what you're trying to do, is come up with the formula. And there's always some kind of a pattern. And one thing that's true too is notice that in this particular one I gave you 5 numbers in order to find the general term. When I give you that many, it's a lot easier to find the pattern. If I just gave you maybe 2 numbers, let's say I gave you the numbers 2 and 4, and I said, okay, come up with the formula. Well, gosh, you could come up with n plus 2, because that would give you 4. I guess it wouldn't give you the 2 because the n is going to start out as being 1. But I could do 2n, because 2 times 1 is 2, 2 times 2 is 4. I could also do any other formula that would give me 2 for the first answer and 4 for the second. So the fewer, I guess all I'm saying is the fewer terms that I'm given when I'm trying to find out what the general term is, the more uncertain I am that the particular formula that I came up with is actually the right one. So when they give you 5 terms, that made it a lot easier to come up with something that you could be pretty sure that that formula was going to work for what you're doing. Okay, so let's continue on with 7.1b.